Okay, so we've talked about arithmetic sequences and geometric sequences. Let's write down the formula for those right here. So there's arithmetic, and here's geometric. And we may need to use those a little bit as we go through this stuff with our sigma notation as well. Okay, so sometimes you can tell if one is arithmetic or is geometric based on the formula. Some of these will just kind of build them out. So some of the questions will ask you to build them out. So I'm going to show you how to do it by hand. And then I'll also show you there's a way to do these on the calculator so you can at least check your answers as you go if it asks you to build them out and that kind of thing. Okay. All right, so starting right here with number 1, the number on the bottom tells you which one to start with. So in this one, I'm going to start with a sub 1. Okay, so that number on the bottom tells you what to start with. The number on the top tells you the term number that it wants you to go through. So in this case, I'm going to do a sub 1, a sub 2, and I'm going to stop with a sub 3. Okay, so I'm going to start with 1. And I'm going to go to the third term. I'm going to start with the first term and go to the third term. So the number on the bottom is where to start. The number on the top is where to end. All right, and then they've given me a formula there, so I can plug into my formula to find each term. So this first one's going to be 2 times 3 to the first power, which gives me 6. And my second term will be 2 times 3 to the second power, which is going to give me 18. And then my third term will be 2 times 3 to the third power, which is going to give me 54. All right, so we've done a lot of work with finding those sequences and finding those terms. The difference is that today, with the sigma notation, now I'm going to go back and I'm going to add them together. So sigma means to find the sum. So I'm going to add those together. In my calculator, I'm going to do 6 plus 18 plus 54, and I get my sum to be 78. Yes, that little sigma right there means a sum or a summation. Sometimes you'll see them use the word summation. Okay, any questions on that one? All right, let me show you a little trick in your calculator. Again, on these first 3, they want you to actually build out all of the terms, so be sure that you do. But you can check your answer by going to alpha and F2 and then number 2. Okay, so on my calculator that looks like that. So alpha F2 gives me these options. And then that number 2 right there will give me a sigma. And now we can type in. Now the tricky part here is that we don't use K in the calculator very much. So I'm going to use X instead. So I'm going to put in X and 1 and then go up here and say we're going to 3. And so then over here in this formula I need to also use an X. So I'm going to do 2 times 3 to the X power. And it'll calculate all of that for you. I know, right? Okay, so alpha F2 number 2. Okay, any questions on that one? Okay, so let me give you a minute. You work on numbers 2 and 3. So build out those terms, add them together, and then check on your calculator. As usual, they didn't give you very much room for that. Okay, any questions on 2 or 3? Okay, all right, on number 4, it's asking me to write using sigma notation. All right, the first thing I need to do is figure out if it's arithmetic or geometric, what my formula is going to be for this. Sometimes it will be arithmetic or geometric. Sometimes you can just look at it and see the pattern, okay? So I'm going to start here with number 4. And on number 4, it's not arithmetic. I'm not adding the same number each time. It's not geometric. I'm also not multiplying by the same number each time. But if this is my first term and my second term and my third term and my fourth term and my fifth term, what do you notice about each of those numbers in the sequence here? They're squared. Yeah, that's right. It's your term number squared. So my formula for that is going to be n squared. Okay, so sometimes it'll go into your arithmetic or geometric pattern. Sometimes you just have to look for what the pattern is. Okay, so I'm going to go over here on the side just because I'm kind of short on room here. So I'm going to write my sigma like that. It's going to start at the first term. Now you can pick any variable that you want to use. I like to use x because that's what I'm going to put in my calculator. So I'm going to go from the first term, and then it tells me that it wants me to find the sum of the first 10 terms. So my number on top is going to be 10, and then next to it I'm going to write in my x squared. Okay. If you want to use n because that's what our formulas are usually in, that's fine. You can see up above they used k for most of theirs. That's okay. Whichever variable you want to use there, it doesn't matter. Just make sure your variable here matches your variable here. So whichever variable you're using, make sure it's the same. Okay. Any questions on that one? Okay, number 5 is also not arithmetic or geometric. It looks a little bit like it would be arithmetic because we're adding 1 each time on the bottom. But when you're working with fractions, remember to add, you need a common denominator. Okay, so that's not going to be an arithmetic. Okay, so what I am going to look at is this is my first term, my second term, my third term, my fourth term, and my fifth term. Okay, I do notice that I always have 1 on the top. Okay, so I'm just going to keep that 1 up there on the top. Okay, and then what could we do to my term number to get the bottom number each time?
N plus 2.
That's right, yeah, good, n plus 2. Good, so on the bottom I've got that n plus 2. Good. Okay, again, use whichever variable you want. It does not matter. If you want to use x, you can say that this is x equals 1. Right, on the bottom. All right, what term number am I going to on this one? 100, good, all right, and then that's going to be 1 over x plus 2. Good. Okay, again, if you want to write it as n, that's fine, you can write it as n as well. I'm sorry, Timmy? N plus 2, because if you look at what I have here, if this is 1, plus 2 gives me 3, 2 plus 2 gives me 4, and so on, so it's just kind of following that pattern. Yeah, good question. Okay, let me give you a minute. You try number 6. Number 6 does follow a pattern on this one. You can use a formula.
So like for the beginning it was given by k.
Yeah.
Is it always going to be equal to 1?
It'll be 1 unless they tell you otherwise. Like you'll see some on the worksheet here in just a minute where they tell you to start with the second term. So you'll want to start a sub 2, a sub 3. But if they're just giving you a list, then we assume that that one that they've written first is the first term.
Okay.
Yeah. Okay, when you're ready, check yours. Okay. Again, if you want to write them with n, that's fine. It would look like this.
So how do you figure that out?
How do I figure this out? So I noticed that it's geometric because if I look at what I have here, I could be adding 3, but if I add 3 again, I'd get 9, right? So then I take my multiply, so 3 times 2 gives me 6, times 2 gives me 12, times 2 gives me 24. So I know it's geometric, which means I can plug into this formula here. Okay, so my geometric a sub 1 is my first term, which in this case is 3, and r is what I'm multiplying by, which is 2. And then I plugged into that formula. Yeah.
Okay.
Good. Okay. So again, if you want to write it with ends, it'd look like that. That's fine. Okay. All right, flip over on the back side. On the back side, they're going to start to, nope, on the next page, sorry, page 7. Not the back side for y'all. Looks like this. All right, so we're going to talk about arithmetic and geometric series and some formulas that we can use. This right here is the formula that I use for arithmetic. I don't use this formula at all, because that top one will work for everything. So, your choice. But I really like that top one. Okay, and then this one down here is the one, and it's labeled pretty well, but that's the one right there that I use for geometric. All right, so if you're working with a series and it tells you that it's arithmetic, you can plug into this formula. If it tells you that it's geometric, you can plug into this formula. So you'll see in just a minute, we'll have some that it doesn't work really in the calculator that well because it doesn't give it to you in sigma notation. So using these formulas really helps out. Very good. All right, let's get down to number 8. So on number 8, I want to find the 100th partial sum, which is what we're finding here, of an arithmetic series where a sub 1 is equal to 17 and d is equal to 4. Okay, so I'm going to start by plugging into my arithmetic sequence formula, which is that a sub n is equal to a sub 1 plus d times n minus 1. So that's this one that we just wrote on the side. This one right here. Okay, so that one's arithmetic, this one's geometric. Okay, so I'm going to start by plugging into that formula. Okay, so that gives me that my formula that I'm using is 4n plus 13. I'm just going to kind of circle that so I can find it. Okay, so to use this formula up here, I'm going to use the formula and then I'll show you in the calculator how it looks, but let's use the formula first. So using the formula, my n value is going to be 100. It wants me to find the sum of the first 100 terms. Okay, I already know a sub 1 is 17 right here for my formula. So there's my a sub 1. So I need to go and find a sub 100. I need to find my last term. So it'll give me 4 times 100 plus 13, which gives me 413. Okay, so my sum of my first 100 terms is going to be 100 divided by 2 times a sub 1 plus a sub 100. So you take your first term and your last term and add those together and then multiply by that 100 over 2. All right, they're going to be pretty big numbers because we're adding a bunch of things together. So I'm going to do 17 plus 413 and then times 50 because 100 divided by 2 gives me 50, and that gives me 21,500. All right, let me first put number 9 into the formula just so you can see that, and then we'll check it in the calculator. All right, so in this one, we're finding the sum of the first 30 terms, so my n value is going to be 30. A sub 1 is going to be 5 times 1 plus 2, so 7. And then I need my last term, so a sub 30 be 5 times 30 plus 2, so that'll be 152. Find your number of your last term, then find your first term and your last term, and then we just plug it in. The sum of the first 30 terms will be 30 divided by 2 times my first term plus my last term. And sometimes these will be negative. It depends on which direction your sequence is going. So if your sequence is getting smaller, then your sum will be negative. That's okay. All right, so I'm going to start with 7 plus 1, 52. And then I'm going to multiply by 15 because 30 divided by 2 is 15, and that gives me 2,385. And again, we can check that. I'm going to go alpha F2 number 2 and put in from 1 up to 30, 5x plus 2. And that also gives me 2,385.
So these formulas are for the times when like the number above the sigma is too much to where you can't like draw all of them out.
Right.
So you just use this formula.
Yeah, like you wouldn't want to go and plug in to find all 100 terms.
Mm-hmm.
Yeah, for sure. Good. Okay, let's look at a couple of geometrics. Let's see, I'm just going to do one geometric, number 11. We can skip over number 10. That's deriving the formula. We're good. We'll jump down there to number 11. All right, so number 11, this time I'm going to plug into this formula here. So for this formula, I need my first term, which I have right here. I need my R value, which I have right here. And I need n, which they've told me to find the sum of the first 10 numbers. So n is going to be 10. The geometric ones, because we're multiplying, get really, really big really fast. So you'll have some big numbers when you do these, and that's okay. All right, so my formula says to do a sub 1 times 1 minus r to the 10th power divided by 1 minus r. Okay. If you would like to use alpha F1 number 1 to help you with this, you can. Or if you're going to do it just in steps, that's okay. Just be careful of your order of operations. Very, very important that you do that exponent first. Okay, I'm going to use alpha F1 number 1. So alpha F1 number 1, and then I'm going to have 5 times 1 minus, and then if it's negative, you need to put some parentheses around this. So let me go ahead and put some parentheses around the 3, just because if it's negative, you'll have to. Won't be a choice. And then on the bottom, 1 minus 3. So if your R value is negative, make absolutely sure that you put some parentheses around this number right here. Otherwise, it will give you a very, very wrong answer. So watch out for that. Okay? All right. So again, big numbers, that's okay. 620. I know. I saw him fly through the room just a minute ago. It's just like the biggest horsefly I've ever seen. Go away, go away, go away. Okay, flip over to your homework, and let's take a look at numbers 19 and 21. They get a little bit harder than just plugging into those formulas, so I wanted you to get to see one of those. So find the 7.3.1 homework. Looks like this. And so the first page is very much like what we just did. Okay, but let me flip over to numbers 19 and 21. The difference here is that we don't know what the last term is, so we have to find the last term. We have to find what term number it is. Okay, so the first thing I'm going to do is determine if this one is arithmetic or geometric. What do you think here? Are we adding or multiplying? Adding, good. So we know that it is arithmetic. Okay, so by knowing that it's arithmetic, I know that I can use a sub n is equal to a sub 1 plus d times n minus 1 to help me find my term number. Okay, so I know that my first term is 1, and I know that I'm adding 3 each time. So a sub n is going to be equal to 3n minus 2. Okay, so distribute that 3n, you'll get negative 3. And then 1 minus 3 gives me negative 2. Okay, so here's where this one gets a little bit trickier. Okay, so for my formula, I need a sub 1, which I know is 1. And I also need my last term, which I know is 295. Okay, what I don't know is how many terms got me to 295. Okay, so I don't know how many times I added. Okay, but I do know that a sub n is 295, So I can plug that in right here and solve for n. So I'm going to say 295 is equal to 3n minus 2. Okay, so 295 plus 2, and then divided by 3 gives me that is the 99th term. So my n value for my formula is going to be 99. Okay, so now we know we're finding the sum of the first 99 terms. So that'll be 99 divided by 2 times 1 plus 295. So 1 plus 295 gives me 296. And then I'm going to multiply that by 99 divided by 2. That time I don't want to do that in my head. And I get 14,652. Any questions on that? Okay, last one we're going to work together is 21. Okay, very similar, except 21, are we adding or multiplying this time? Multiplying, good. Okay, so we know that this one is geometric. Right, for geometric, I'm going to say that a sub n is equal to a sub 1 times r to the n minus 1 power. Okay, I only have to go through these steps because they've given me the first term and the last term, but they haven't given me what term number I'm working with. And that's what I need for this formula. All right, so let's see here. I know that my first term is 1. My r value, I'm multiplying by 3 each time. That one isn't really making a big difference, so I can just say that a sub n is equal to 3 to the n minus 1 power. Okay, this is a sub 1 right here. And this is my last term over here, 2187. Okay, so I can take that a sub n and I can plug it in right here to find which term this is. Okay, so I'm going to say that 2187 is equal to 3 to the n minus 1 power. Okay, now if I kept the number that was in front of the 3, in this case it was a 1, I would need to start by dividing by the 1. Okay, so like if you had 2 times 3 to the n minus 1, start by dividing by 2. I didn't in this case. All right, so now it's when I use those logarithms that we used, I think, on Friday last week. So I'm going to start with the 3 being my base. So I'm going to say that this is the log base 3 of 2187 is equal to n minus 1. Okay, and to find that logarithm, I'm going to go to alpha f2 and number 5 again. So in your calculator, I'm going to go alpha f2 number 5, and it'll give me that logarithm that I can fill in there. So that's 3 and 2187. That gives me 7, but be careful, that's where 7 is equal to n minus 1. That's right, so I need to add 1. So my n value is going to be 8. So now I know that that is the 8th term. So 2187 is the 8th term of this sequence. All right, so I'm going to find s sub 8, which is a sub 1 times 1 minus r to the 8th power divided by 1 minus r.
Where does that equation come from?
Right back over, where'd my exploration go? The second page of your exploration that we just did. I just can't find mine. Yep. If you hadn't asked, I'd be. Oh, here it is. There it is, right there. On the part 3. Yeah, look at part 3. Use that formula right there because it's geometric. We use that formula right there. Good. If you hadn't asked, I've been able to find it.
Part
2 is arithmetic. Yes.
Okay.
Yeah. So if you're doing an arithmetic sequence, use the one on part 2. If you're using geometric, use the one on part 3. And use the top one. Don't use the middle one on part 2. That bottom formula is weird. Okay, alpha F1 number 1. I don't really need the 1 times, but you can put it in there if you want to. 1 minus 3 to the 8th power. Oops. Get out of the exponent there. And then divided by 1 minus 3. And that gives me 3,280. You see that? There we go. Better. Okay, so I will give you some time to work on the rest of this one, and we'll have some time tomorrow in class to work on this homework. It's a little bit long, and what we're doing tomorrow is very, very short and doesn't have any homework that goes with it. So I'll give you today, the rest of today and tomorrow to work on the 7.3 homework.
Can we do all of them?
Yeah, go ahead and try all of those. Yeah, they all have kind of some different pieces to them, so it would be good to do all of those. Yeah, I was going to say, let me grab that one from you. Let me stop this. Okay.